Same what and what? Same size and same shape. Very good. So same size and same shape. Okay, so that means that if I'm looking at one triangle, it should look exactly the same as the other one. So yes, Cody put same sides and angles. And actually that's true. What makes up a triangle is the sides and the angles. And that's why we were classifying by sides and angles. So when we say corresponding angles, what that means is that when I'm looking at this triangle, I'm seeing that angle A is congruent, like they marked here, to angle D. So that's just to say that, let me switch the color so it's more obvious. So we're going to do what I call a ring mark. Okay, the ring mark is to say A pairs up with D. Okay, B corresponds with E, and C corresponds with F. So all three sets of angles are congruent to each other. And we can do the same thing with the sides, right? And it's listed off at the bottom right here. AB is congruent to DE, BC is congruent to EF, and for sides, we've been using tick marks. So the 3 tick marks is to indicate that the pair of angles with the 3 tick marks are congruent to each other. Okay, so you'll notice that there's 6 relationships here, 3 with angles and 3 with sides. And that becomes important later on when we know that the triangles are congruent. We might be referencing corresponding parts, and the corresponding parts are the angles or the sides. So down below here, we talk a lot about like, oh, well, all the corresponding parts are congruent to each other, all the corresponding angles and all the corresponding sides. And so we're going to use that as a justification eventually, as part of the definition of triangles being congruent, is that all their corresponding parts are congruent to each other. So if you guys have a highlighter, if I can have you guys highlight this statement right here. And I still remember learning this statement in geometry and just like remembering that the abbreviation for it, and it's been so many years, but I still remember it. And I know you guys are like, well, you teach it, Mrs. Kim, but I actually literally remember being in class learning that statement. So it's CPCTC, and that abbreviation stands for corresponding parts. It's the C, the P of congruent triangles are congruent to each other. And again, that's to say the angles that match up with the angles, the corresponding angles are congruent. The sides that match up with the sides are congruent to each other. So we're going to practice a little bit with notation. Okay, so one of the important things to keep in mind when you guys look at a congruent statement is that the order of the letters matter. So if you look at the figure down below here, when I see this congruent statement, I know that even without a picture, that W, and I'll highlight it so it's color-coded, that W and A are congruent to each other. So on my diagram, when I say mark the diagram, I mean like do the ring mark and the tick mark. So angle W is congruent to angle A. I have the next letter that I'm going to highlight in pink is X, and X is congruent to B. So again, the order of it matters. So X, double ring mark, B, double ring mark, and then the last letters are X and F, or sorry, Y and F, and that's triple ring marks here. And so that's me labeling all the angles. And usually with the angles itself, that's enough for me to then start practicing with making sure that I understand that I'm actually making the correct congruent statement. So we're not going to do all of these, but for question 7, you guys, in the chat, in the private chat, can you type out what side is congruent to X, Y? What side do you guys think is congruent to X, Y? Okay, if you typed in BA, can you guys look at it again? But for the most part, I think everybody got it. If you guys typed in BA, can you look at it again? Look at the figure again. Okay, whether you guys typed in BF or FB, that's good. That's referring to the correct statement. So BF or FB. Okay, so just if you look at, well, how can you tell? Because someone put XY, or sorry, someone put BA. Okay, so how do we tell? If you look at X, Y, X is the double ring mark, and then Y is the triple. So we want to find the double and the triple ring mark and then label the segment accordingly. I saw someone put angle BF. This is a side, so we want to make sure we use the appropriate notation. It's a segment BF. Okay, let's try another one. Can you guys try, and actually I want to see this one. If on the tests, which on the quizzes and tests, that's going to happen, is that they want you guys to write the correct statement of congruence. This is called a congruent statement for triangle. What would go here if I rearrange the letters? Triangle YWX is congruent to triangle blank. What should that triangle be? If you had FBA, can you double check it again? If you had AFB, can you double check it again? So figure out what angles correspond with what angle. Okay, so the majority of us, good. The majority of us put triangle FAB, right? Triangle FAB. And again, we want to use the tick marks or the ring marks to help us out here. Y has 3, so I want to begin with F. And then it went YW, which is 3 to 1. So I want to do 3 ring marks to 1, so FAB. And then also, even if I didn't have this diagram, I can go back to this statement right here. If you guys find Y in your initial statement, it's the last letter. The last letter here is F. Then the next letter they went to was W, which is the first. So we're going to go back to the first, FAB. So that's using a congruent statement to rewrite as a different congruent statement. Okay, as just extra practice, can you guys try number 12 for me? BFA. If we rearranged it to be BFA, what's the correct order? Good, the ones coming through are correct. Good. Okay, 100% of you guys are getting that. So very nice. So it's triangle X, Y, W. And oftentimes on quizzes and tests, we have this written out for you guys, and you fill this in just because it makes it easier for us to check there is a certain order, and there's only one answer that is correct. Okay, so down below there, you guys have 2 quadrilaterals, and we're saying that those 2 quads are congruent to each other. And then based off of just the ring marks alone and the tick marks, can you guys answer question 20 in the chat? What is angle E congruent to? There's 3 angles that are congruent to angle E. Can you guys list out those letters? Excellent, you guys. So angle H, and remember when we refer to an angle, we have that symbol there, angle K and angle N. Very nice. Okay, so I think that's all I'm going to spend on congruent figures because I want to focus in on what this chapter is about, and it's all about triangles, this chapter. And then the next chapter is about parallelograms. So up above here, I skipped one thing. So can you guys find the part where it says common side? And I want you guys to, I know we're on triangles, but it's just hard to envision a triangular room. So I want you guys to draw a rectangle. And then I want you to picture 2 rooms that are adjacent or right next to each other in your house. Okay, so assuming this is your room, and then let's say this is your, well, let's call this the living room. Okay, so if your room is next to the living room and you guys share this wall, if you were on one side, if you were in your room and you measured the length of that wall, and then your mom or dad was in the living room and they measured the length of that same wall on the other side, would you guys expect the measurement to be different or the same? Would the measurement of that wall be different or the same on opposite sides? Okay, it would be the same, right? It would be fair to say that the length or the measure of the length of that wall is the same on either side. So we would say if I attached letters to this and called this segment AB, that segment AB is congruent to segment AB, okay, with those segment symbols on top. And that there was a property that was tied to that. Does anyone remember all the way to unit 1, what that property was when we said something is congruent to itself? Like 2 is congruent to 2, or 3 is congruent to 3. In this case, AB is congruent to AB. Very nice, Mia. I didn't expect very many of you guys to remember, but this is reflexive property. We're going to use this so much. Okay, so if there's a shared side or shared angle in a figure, we can assume that that shared side or angle is congruent to itself. So that's AB is congruent to AB by reflexive property. Okay, so if you guys can find the next page for me, and some of you guys do have to search, we were on page 9. Now we're going to be on page 10. And so if I had to kind of give you guys a synopsis of what this next today and then the next day is going back to the top. Okay, so if I gave you guys 2 triangles, you're like, Mrs. Kim, do I really have to show all 3 sets of angles and all 3 sets of sides are congruent in order to prove that these 2 triangles are actually indeed congruent to each other? And I'll tell you guys that I'll just say that's too much work. You guys have shortcuts, and the shortcuts are going to be that you only need to show 3 sets of something are true. Okay, and one of those is going to be show all 3 sets of sides are congruent. So let's say that you guys know it's given, okay, what I'm marking off, that MR is congruent to TW, that you guys have RS is congruent to IW, and lastly that, and I think this is what the last class mentioned, that this is actually that MS looks more congruent to TW. So let's make that true. Okay, so let's mark MS as the single tick mark and TW as the single tick mark, and then MR as our last or third side. So knowing nothing about the angles, the shortcut now will be, if I know all 3 sets of sides are congruent, I can make the statement that the 2 triangles must be congruent to each other. So I would say that that's one shortcut. And from here on out, if you're like, you look at that and you're like, oh yeah, those 2 triangles are congruent. And then when I ask why, you guys can simply say side, 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 or SSS. Okay, so all 3 sets of sides are congruent. S stands for sides. Okay, the other 2 are the ones that we're going to cover today. One is side angle side, and that is if you happen to know that one set of sides are congruent to each other, another set of sides are congruent to each other, and then we introduce this word called included. Okay, and I'm going to describe it to you guys, and then you're going to tell me what you think the included angle is. Okay, an included angle is the angle that is between the 2 given sides. Okay, so if the side is LM and EM, what do you guys think the included angle would be between LM and EM? What's in between, or kind of like sandwiched in between those 2 sides? Go ahead and type it into the chat. And an angle is just a vertex, right? Yeah, so very good. It's angle M. Angle M is between the 2 sides. So given that M and A are included between those 2 sides, we have here, and when I have you guys label eventually, this is a side, this is an angle, and then this is a side, where the angle is included between the 2 sides. So if I know that that's true, and I can say, this side is equal to this side, this angle is congruent to this angle, and this side is congruent to this side, then I can say, okay, that's my shortcut way of showing that those 2 triangles are congruent, simply by side angle side. Okay, the last one is angle side angle. So for this one, instead of the sides being on either side of the angle, you have now that the side is the included piece. Okay, so highlighted part, this involves an included side. So let me mark off the angles for you guys, and you tell me what you think so angle T is congruent to angle N, and then angle I is congruent to angle G. What do you guys think on the left triangle? What's the included side between the 2 angles? What's the included side on the left triangle? Okay, what's the included side? Good. between the two given angles. Very good. So if I happen to know an angle, a side, and then an angle where the side is included between the two angles, then I can also show, that's another way of showing that the two triangles are congruent, and that's by what we call ASA. So I wrote that in big, kind of like bigger letters here. I'll box it. Those are justifications for why triangles are congruent, and think of those as shortcuts. We don't have to show all of it is true. It's just the just that particular set of angles and sides. Included means in between. So if you want to say in between, so I would describe TI as being in between angle T and angle I. Yeah, but we would say, for example, someone said, oh, but there's no point in, it's like RI is not in between these two angles. Okay, RI is like, if I were to read it in consecutive order, I would say this angle, this side is right next to it, and then it's in between this angle and this angle right here, this side. Okay. All right, so the big focus again in today and then into Friday is going to be just getting you guys comfortable. And tonight's all about fill in the blank proof. So I think you guys will be fine with it. But we'll do a few of these together just to make sure you guys feel comfortable with it. So if I can have you guys write statements and reasons here. We'll do 2 together, and then I'm going to have you guys do a breakout room, and then we'll come back and finish it up. Okay, so you guys have statements, you have reasons here. And under the first statement, you have OK bisects angle MOT. And also that OM is congruent to OT. So I'll start with marking off what's given. Okay, so what's given to me is OM is congruent to OT. If you guys look at the picture, what else could you guys say is, if OK bisects MOT, what would you guys say is equal to each other? What would you mark off as congruent to each other? If OK, and you want to think of OK as the knife, and it's cutting the angle MOT in half. That's what bisects means. Uh-oh, and I guess I should clarify this, you guys. Is it bisecting a side or is it bisecting an angle? Okay, if it's bisecting an angle, what angles must be congruent then? Okay, good, Lily. Yes. Okay, so you guys want to double check. Okay, what is this bisecting? Is it bisecting a segment or is it bisecting an angle? So we again want to think of OK as the knife, and it's cutting this angle in half. So if it cuts that angle in half, then on my diagram, I'm going to mark angle 1 is congruent to angle 2. Okay, so angle 1 is congruent to angle 2, or MOK is equal to TOK. That one's correct too. Okay, so what do you guys think the reason is? Marked off 1 is congruent to 2. We said we bisected an angle. Very nice. Definition of angle bisector. That's what an angle bisector does. It cuts a bigger angle into 2 congruent angles. Okay, then someone already went into the next step. But if you guys want to, like when we're trying to prove triangles are congruent, we're trying to get to one of these 3 reasons being true. Okay, so now look back at the diagram. Now you guys are in rooms that are not rectangular, but you guys are in triangular rooms, right? And you have a shared wall. Can you guys state what do you know is true then? If those 2 triangles are rooms and you share a wall, what must be true? Okay, that shared wall must be congruent to each other, right? Very good. OK is congruent to OK, with segment symbols being with that little bar on top. OK is congruent to OK, and that is by reflexive property. Someone said that the line bisecting, that when it says it bisects an angle, that's all it does. It just bisects the given angle. All you can assume is that 1 is congruent to 2. It has nothing to do with the line itself or bisecting segments at all. Okay, so what I just assumed was that this shared wall, right, OK, is congruent to itself. Okay, so then now I want you guys to label. And by label, this is what I mean. Go back to your diagram, and you guys have this. If you just focus in on even just, I think maybe this will help you guys a little bit. If you just focus in on this triangle, okay, and you look at what you marked off, you have a side here, you have an angle. Do you guys know that these two triangles are congruent? And if yes, what's the reason for it? Okay, good. Yeah, so please label it, like label SAS like that, because then I'm getting not you guys, but my other peers, they would say, oh, it's angle, side, angle, or it's side, side, side. So you want to make sure you label what you have in maybe just one triangle, the way that I did it there. And then that way, you know, triangle MOK is congruent to triangle, looks like TikTok, huh? So triangle talk. And that's by side, angle, side. All right, so let's do one more. Okay, so on this one, page 11, go ahead and find page 11. We're going to mark off and write out what's given to us. So we're given HI is parallel to GJ, and also HG is parallel to IJ. Okay, so remember the way we marked off congruence was these little arrows here. And then these arrows here. Okay, so just a quick refresher into the last chapter. Do you guys remember when you were given two lines are parallel, you made certain assumptions about angles, or we were given postulates, we were given theorems that said if we had the letter Z, for example, if you guys had the letter Z, that you knew these angles were congruent to each other by alternate interior angles. You guys had things like, oh, we know this angle is congruent to this angle by CA. So anytime they give you guys information on parallel lines, that's going to give you guys information on, and you know, I should say this, on angles, not sides. It doesn't mean that the sides are congruent. It means that something about the angles are congruent. Okay, so what I want you guys to kind of like get into the practice of doing is looking at the letters. Like, okay, I have a letter Z here. From that letter Z, what two angles are congruent, you guys? From the letter Z that I just drew, what two angles are congruent? Okay, so that letter Z was drawn with the bottom and the top parallel lines, so 1 and 2, and very good. If you guys went in the opposite direction, 3 and 4 also are congruent to each other. So that's this next statement right here. And so what's the reason for that? How do you guys know 1 is congruent to 2 and 3 is congruent to 4? Okay, so good. That's AIA, very nice. And then another attached room, right? You guys have two triangles attached to each other. So what do you guys know is congruent to itself here? And I'm going to go ahead and mark off the angles as well. Okay, so they gave us the reason, and very nice. HJ is congruent to itself. HJ is congruent to HJ. So let's mark that off. Now, if it helps, why don't you guys color in one of the triangles and then write out what you guys have. Like, so if I write out what I have an angle here. What's the reason, you guys? Why are those two triangles congruent? Yes. Okay, so good. And you have two sets of angles and then the side that's included in between. Very nice. So the official reason is angle, side, angle.